All right. Good morning, everybody. Welcome to track one. We have Jake Williams. My name is Jason Blanchard. Thank you so much for coming to WWHF Hackin Fest. If you've never seen Jake speak before, you're in for an experience. I had the pleasure, one of my favorite experiences with Jake ever was the day that his Darknet Diaries episode came out. Has anyone here heard of Jake's Darknet Diaries episode? If you haven't, I highly, highly recommend listening to Jake's Darknet Diaries episode. In fact, make a note of it to do when you get home to listen to Jake's Darknet Diaries episode. But I got to hang out with him like the day that dropped, and I was like, this is so cool. Anyway, Jake has been a friend for a long time. He is a fantastic speaker. He is probably one of the smartest people I've ever met in my entire life. And last year, I married him. Yeah. And so also his wife. I married the two of them to each other last year. My wife always hates this story when I'm like, I married Jake Williams. And she's like, that's not funny. All right. So, Jake, it's all yours.
Hey, I appreciate it, man. Definitely. And Jason as well, you've been a fantastic friend over the years. Really, really appreciate the friendship, man. So, hey, my name's Jake Williams. I really wish I had a lapel mic, but I'll be holding this. If I hold it too far away, like, do the little ear thing so I know that I'm dropping out. Wait, oh no, you have extra ears. That's cool. Okay, so anyway, so I'm going to talk today about challenges and war stories for AI risk assessment. I want to start by noting I am not an AI doomer. It's probably going to come off that way. Right? I've had people tell me that it comes off that way. Listen, I'm a risk management professional. My job at its core is to explain risks to the business in a way that they can understand. And so I probably do come off a little bit doom and gloom because I am talking a lot about risk. But I'm here to help the business move forward safely, smartly, hopefully in a way that just doesn't expose them or overexpose them to too many risks. I also, just for the record, I hate AI. Right? I hate it. I absolutely hate it. If you want to hear me rant about the ethical issues around, OpenAI or how Sam Altman is an absolute ass clown, come grab a drink with me. I will happily talk all day long about just all of the absolute badness of the AI industry. But we are saddled with this one way or the other. Unlike a lot of folks in cybersecurity, I actually have a background in theoretical computer science. I've done a lot of machine learning. I've done a lot of AI. That backs out to 2008 at the Institute for Defense Analysis. And so as the generative AI wave has come on, I'm in a good position with my security background as well to help folks. I'm also doing a lot of AI development for folks to help them build apps safely, right? But in doing so, I found a lot of common patterns in our risk assessments. A lot of common patterns in the risk assessments. So now my clicker's not going to work. That's going to be great. There we go. So here's my agenda. This is what we're going to cover. You'll find out I'm not a big slide reader. I'll probably tell stories. The slides are for your reference. They should be in the Discord channel any moment, but take photos of them if you like. Here's my bio. That top one's going to be a little tough since I believe we've been designated a terrorist organization, but I am the Supreme Allied Commander of Antifa. I run all of their infrastructure. Come get me, bro. Anyway, I've done a lot of forensics over the years. I was an NSA hacker, all kinds of fun stuff. Russian intelligence formally endorsed my hacking skills. I loved that. Well, not at the time, but it's cool now. Really? Okay, well, I guess we're not. Nope, we're just manually advancing slides. So this guy standing up here beside me is Aiasaurus regex. And so my partner loves to go thrifting. We flew in here Sunday. She loves to go thrifting, loves to hit the antiques shops, what have you. And I hate it. I absolutely hate it. And so what I try to do is I try to punish her a little bit by finding something absolutely hideous, right, that I can buy and bring home with me. This guy has grown on me. I bought him as the class mascot, and he's just grown on me. So I'm trying to figure out how to get him home or store him here or whatever. But all that said, let's get into challenges in AI risk assessment. First, the problem statement. Are we deploying AI? Yes, we are, right? And so if you're not familiar with those folks, that's from the now defunct ShmooCon. But let's talk about why AI risk assessments are really hard, other than the fact that people are shoving it down our throats. First off, and if you take nothing else away from today, this is it. Generative AI models are inherently non-deterministic. Now, that's a big $50 word. That means probabilistic. It means that every output is a roll of the dice. We do not get consistent outputs. My friends, all of our security models, every mental model we have for security is built around deterministic systems. A given input guarantees a given output. Generative AI models do not work that way. And when we build them into our apps, this is really bad for testing, or it makes testing really, really, really difficult. I should note that you can tune parameters. Some folks come back to me like, Jake, OpenAI has the option where you can create an almost deterministic application. They even say almost, right? Because it's mostly, but not always. And I'm like, cool, but are you going to run it that way in prod? Because I've tested it that way, right? I've tested OpenAI's APIs where I put them into almost deterministic mode. And let me tell you, they're a train wreck, right? It's like, it really is like going from GPT-5 to autocomplete on my phone, right? The quality just isn't there. The apps don't run appropriately. So no surprise, the business turns around and says, turn that crap off. Well, great. So now I have a huge delta between what we tested and what we actually have in prod. Do not enable this for testing. Look, for app development testing, rock on, absolutely do that. For security testing, absolutely not. This is a resume updating event waiting to happen, right? So, second thing I want to talk about here is that in most AI applications that I work with, LLMs aren't relevant to much of the application, or most of the application in a lot of cases. In most places, we've got a workflow that's building the LLM in, invoking the LLM at LLM, by the way, for folks that aren't aware, is large language model. It's what underpins most of our generative AI. I realize that I should have covered that earlier, but alas, we have to focus on where that large language model is used so that we can appropriately model threats in the system. This is another big takeaway, and you're going to hear me talk about this again. You cannot effectively perform black box testing. You cannot effectively perform black box testing on LLM-enabled applications. It just cannot be done. I fight and fight and fight not to do that. And sometimes folks are like, shut up and take my money. In which case, I literally tell them, we are lighting money on fire, right? I'm happy to do the testing, but there's tons of false negatives, and oh, buddy, does my report specify that? There's all kinds of caveats about all the stuff that we probably missed because we're doing black box testing, right? And so this becomes really, really difficult. I want data flow diagrams for the application. You'll note I use the word demand, right? I demand data flow diagrams for the application. Now, I know in the day of Agile, it's very, very difficult to get data flow diagrams because they usually don't exist, right? And so this is where I like to sit down with teams. I typically scope this out as a workshop, right? So basically a scoping workshop where we sit down for a day, sometimes two, depending on the complexity of the application, and we build out data flow diagrams. And that's so that we can actually go and start scoping the test correctly. If I can't do that, if they aren't available, if nobody will let me build them, this is where I like to go in and start trying to log all the back-end LLM calls. We probably don't have enough logging in the application. I'm going to talk more about that in a bit. But I already said if you only take one thing away, make it the whole non-determinism thing. The second thing I want to talk about here real quick is Langsmith. How many folks are familiar with Langsmith? That is not nearly enough, right? So you want to become intimately familiar with Langsmith. It is the skeleton key for fixing the logging problem. Now, the word fixing is doing a lot of heavy lifting there, right? It is the skeleton key for adding logging to an application without major refactoring, an LLM-enabled application, without major refactoring. Basically, what's happening here is Langsmith, built by LangChain, is a SaaS platform that allows you to wrap pretty much any standard AI call, right? So a call to an LLM, whether you're using OLLAMA, OpenAI API, all the standard APIs. Basically, at its most naive instantiation, it takes exactly 2 lines of code. I can't get developers to refactor applications so that I can get good logging, but I can get them to add 2 lines of code. One to import the library, one to wrap whatever standard call they're using. And then every time they make a call to the large language model, I get a copy of the prompt and the response in the Langsmith application. Of course, I pay through the teeth for this, right? Because it's a SaaS platform that's doing a bunch of logging and a bunch of storage, right? And so you're paying through the teeth for it, But again, way, way, way cheaper than refactoring an application from scratch, right? There's a bunch of caveats here. I should note, I lose all of the context, right, around why that call was made to the LLM, but at least I have that part. By the way, the large language model, that's the non-deterministic part. That's what I really care about the output for. And if the dev isn't logging it, this is the skeleton key to get it turned on immediately. Whew. Who likes reporting in a pen test? You like reporting in a pen test? Yeah, so Jeff McJunkin apparently had the same reaction. I was going to say, then you're weird, right? I mean, we're just going to call it, right? Look, no one, okay, not no one, we've got somebody in the front row who does, but most of us, let's agree that most of us dislike reporting in a pen test. I doubly so dislike reporting in pen tests. But when we get into LLM-enabled applications, reporting findings gets ridiculously difficult. The problem here is that ultimately, because my findings are not repeatable, and be real, they are not repeatable due to non-determinism in the vast majority of cases, right? I may run a test, I'll come back to this in a minute, I may run a test 1,000 times, 2,000, 5,000 times, and I may get one case where I break the app. Well, that's not repeatable. Now, it's the same test being rerun again and again and again and again to go generate that one case, right, of basically the one case where I'm actually exploiting the app. This is not a repeatable finding. It is a finding. Be very clear, it is a finding. And threat actors, they have time that your devs do not. And the threat actor will happily recreate that finding for you in prod if this doesn't get fixed. So we have to pre-negotiate with our stakeholders. We have to level set with our stakeholders. What are finding acceptance criteria? How do we need to rejiggle or rejigger or what have you, readdress, redefine, right? Ultimately those acceptance criteria for our reporting of our findings. I want to highlight here that, I've been doing exploit dev for, almost 2 decades, right? And so there are a lot of times, particularly as I get into address space layout randomization, I can't break ASLR, but I can still say there's an exploit here, right? It's only going to be successful one of n times, and I can calculate out exactly what n is, right? I can say, hey, here's the size that I'm jumping into, right? Here's the maximum range, so 1 in 10,000, 1 in a million, 1 in whatever. I can't define that here. And so I can't organize my findings by likelihood of success, right? Because any test, right, any one of those tests could ultimately, or any one of those invocations of that test could ultimately exploit the app. And so I here organize by impact, not by likelihood of exploitation success. I just can't define it accurately, right? I mean, I can say objectively, I ran the test 10,000 times and it showed up once, right? But that doesn't mean that if you go run the same test 10,000 times, it won't show up 5 times, 10 times, 11 times. Again, it's a wholehearted roll of the dice. So let's talk about common findings in AI risk assessments, or AI application risk assessments. I'm going to tell you, again, I started with, I hate AI. I hate AI risk assessments even more because I got to tell you, I feel a lot like Bill Murray. Well, not that Bill Murray. I mean, kind of that Bill Murray. I feel a little dead inside, but more like this. It's Groundhog Day, where everything happens again and again and again. We should expect this, by the way, right? How many of you, I'm looking around here, I see a few of you old enough to remember Web 2.0, right? And I mean Web 2.0 when it first started. And maybe you were in app risk assessment or pen testing when Web 2.0 with Ajax, right? Remember Ajax? Yeah, right? When that first was around, who did app assessments during that time? Who saw the same findings on every app assessment? Yeah, exactly, right? This is that all over again, right? The root cause is not surprising. In both cases, right, Web 2.0 and now add an LLM to every application, folks are taking developers and they are literally throwing them under the bus. They're saying, hey, here you go, you're a developer, you're smart, you'll figure it out. We know how the story ends, right? So we see the same stuff over and over and over again. What is it specifically that we're seeing? I'm going to walk through 5 categories of things that we see again and again and again, and then we're going to talk a little bit about potentially how to fix some of them. So prompt injection. First off, prompt injection occurs because the application, because the LLM specifically, has to parse a prompt that includes both context and instructions. Context is data, instructions are code. If you are trying to explain this to somebody, I use the analogy cross-site scripting more than anything else to explain prompt injection, particularly my developers that already have an understanding of cross-site scripting. I'm using an anchor that they already understand. And I like this for a lot of reasons. First off, we've known about cross-site scripting for more than 2 decades. Is it fixed? No, it is not a solved problem, but it is an infinitely easier to solve problem than prompt injection. And the reason for that, right? By the way, too, cross-site scripting is a phenomenal analogy. Cross-site scripting at its core is confusing or tricking the browser into treating data and interpreting it as code. That's exactly what's happening in prompt injection. I want you to step back, and I'm going to take out all analogies, or I'll first note here, all analogies break down somewhere, right? This one breaks down a content security policy, but take CSP out for a second. How do we largely combat cross-site scripting? We try to anchor on script tags. Now, there's other ways to invoke JavaScript, I get that. Just roll with me for the analogy. We look at HTML tags, we look at the formatting, the syntax, and we anchor on that as what we're going to block. This is where I have phenomenally bad news for you. We cannot introduce syntax in large language models. The whole value proposition of an LLM is that we can use plain language, right? Plain language interpretation and natural language processing. And so if we introduce syntax, we simultaneously kill, there are, by the way, some academic LLMs that do introduce syntax, but you kill the value proposition. This is where I have to tell folks that prompt injection is a feature, not a bug of LLMs. You will not fix this. The only sane way to address this is to put guardrails around every place that the LLM returns data back to the app. You have to presume the LLM is returning hostile data, not untrusted, hostile data back to the application. That's the only sane way to address this. So let's talk about our next piece here, and that pivots very, very well into the hostile output. It's insecure use of LLM output. I now have worked multiple engagements where someone has tried to filter out input, right, to say, hey, don't, because I mean, we filter all user-supplied input, but we don't take stuff coming out of the LLM as if it's coming through a trust boundary for some reason. We treat it as if that's data coming from our infrastructure. Well, it may be data coming from our infrastructure, right, but this is where I analogize back to second-order SQL injection. If you're familiar with second-order SQL injection, this is where a threat actor has put SQL injection strings into a database already, database or their data store, and then later causes those to be retrieved and used in non-parameterized SQL. This is one where the threat is coming from inside the house. And again, same thing here, right? The LLM may be under our control, but the threat is still coming from inside the house. I have worked now multiple engagements where the organization had blocked the specific input, right? They wouldn't allow a script tag. They wouldn't allow the SQL injection string. They would filter that out if supplied directly by the user. So what did the adversary do? They described how to build a cross-site scripting payload in plain language. Good luck filtering that, right? I mean, it is doable, by the way. You just have to use another large language model to do it. This, of course, increases latency, it increases cost, it increases development complexity. You have to figure out what your failure path is going to be. You will have some number of false positives, right, and false negatives because of non-determinism. This is a hard problem to solve. It is not possible, right? I go into full Hulk smash mode when I hear somebody say, just sanitize the input, right, that we get from an LLM. And the reason I go into Hulk smash mode is that people that are saying this, they are regurgitating something that they heard someplace without ever having done it. Because the devil, my friends, is in the details. It's really easy. No, actually, it's not. It is easier to sanitize structured data. If I know, for instance, that a particular form field should only ever include a phone number, it's pretty easy to look and say a $sign or I don't know, a backtick or what have you should never be part of that phone number field. I can't do that when I have unstructured data of variable length, size, etc. Yikes, right? And so we're continuously seeing this. With agents, we're seeing a bunch of server-side request forgery. We're seeing a lot of command injection with agents as well. I just read about seriously, just this morning, read about a case, and I I've got to tell you, my daughter just started college. So she's a freshman in college now. She's working in her first semester. Woohoo! She used to break into banks with me and stuff, and so Child Social Services got involved more than once. Fun times. I thought she would grow up to be a hacker. She's in early childhood education, right? And so, okay, right? Still proud dad moment. I have to pay for her, college somehow, and so I can't encourage you enough to continue vibe coding. Please, please, please continue vibe coding. Low code, no code frameworks for the win, right? Move all your developers to those. I have to pay for her college somehow. But I read this morning an instance where somebody was vibe coding and ultimately was building, I think it was called the NX package. And they vibe coded a commit that ultimately would basically read a title from something and then execute it as an argument to another command in bash. And the hair on the back of my neck just stood up, and I'm like, oh my gosh, but this is an orchestration framework, right? And so it turns out that some other folks vibe coding using the orchestration framework. So not only is the orchestration framework itself NX vibe coded, but folks using it, right, were also vibe coding their way through and got a bunch of crypto keys or wallet keys ultimately stolen. And I'm like, woohoo, right? Because look, if you have to steal from somebody, make it a crypto bro, right? Anyway, okay, moving forward, right? So improper authentication. Authentication is hard. We've sucked at it for years when it comes to cybersecurity. Authentication LLM-enabled applications, doubly hard. In a lot of cases, there just isn't a way to accomplish what properly with authentication. There isn't a way, particularly in agentic, to accomplish what the stakeholder has in mind. And this makes devs do really, really bad things. I'm going to use an example here of Copilot Studio. Anybody use Copilot Studio at all? I mean, you can admit it. I do, right? I've used Copilot Studio. I'm not saying I want to. I'm saying that I've been forced to on multiple occasions. And there's a checkbox in Copilot Studio when I make a connection or when I have invoke a connector. And basically what it says is if I publish an application and I publish it to, let's say I publish it to JSON, right? The question becomes, does it use JSON's credentials to call into that connector, or does it use my credentials, the publisher of the app, to call into that connector? If I leave the checkbox enabled that says use Jake's credentials, that's spoofing. That's in a commercial framework that's supposedly enterprise ready, go Microsoft, right? Enterprise ready, and that they're encouraging people to build apps on top of. Now, I'm not saying that that's always an insecure design pattern. There are times that that can be secure. You should absolutely threat model to know if you're in one of those situations. Most people using Copilot Studio can't spell threat model, let alone stride, right? But that is spoofing by definition, right? And so I'll note here that your best bet here is to spend time threat modeling how authentication is being performed in an LLM-enabled application. I don't have the back-end story yet on what happened with SalesLoft. Does anybody know what SalesLoft is? You familiar with this? Yeah. How many folks were hit by SalesLoft? I was, right? And so some folks hit directly, some folks hit indirectly through vendor risk management, third party, what have you. SalesLoft is an application, or their company, specifically SalesLoft's Drift application that was first compromised. But Salesforce started looking at it, and they're like, oh no, and they ripped out all of SalesLoft's authorization to connect to Salesforce entirely. This is the big one that was in the news. If you heard about a Salesforce breach, it wasn't Salesforce, it was a third-party integration. And it was a third-party what? Chatbot. Darn Skippy, right? I am reasonably, I won't say reasonably certain. That sounds legally bad. Let's go with, I am not a betting man, but I'll put down money on just about with anybody, that they were storing credentials in the app in a way that the LLM could see them. And the golden rule of large language model enabled applications is if the LLM can see it, the LLM can leak it, right? And I would bet just ridiculous amounts of money, right, that's exactly how that breach occurred, impacted over 700 organizations at least that we know of, right? And I'm sure the number is higher than that. So think about how credentialing material could be captured and how trust relationships can be abused. If you've taken Bo Bullock's class here over at Anti-Siphon, where he talks about breaching the cloud, a big chunk of what he covers is abusing trust relationships. This is no different, right? So identity governance and entitlements management. Agents should run under a non-human identity. What makes an agent an agent? Autonomy. Autonomous operation, right? That's what makes an agent an agent. Otherwise, agent is just a marketing term, right? Now, if I have something that's operating autonomously, it darn sure should not be operating under my identity. If it is, we have a whole non-repudiation problem. That's the R in Stride, by the way. So we have a new repudiation or non-repudiation problem here. So I have to make sure that I have some handle on identity governance. So agents must run under non-human identities, or some folks call those service principles if you're in Azure. The bottom line here is that there's a key decision ultimately in building agentic applications. You have to start literally from the ground up and say, am I going to provision an identity that has all the permissions that the agent will need to do all the tasks that I'm going to ask the agent to do? That, my friends, sounds really bad. Well, unless you're trying to get incident response money to pay for college, in which case, go, right? But sounds really bad. We're breaking least privilege here. My only alternative is to then break the agent up old school Unix style. Note, I'm not talking about GNU Linux where bash has a TCP stack in it, because who needed that? I'm talking about old school Unix. Do one thing, do it well, right? If you need to do another thing, pipe the output of your command into the input of another command, right? And so this is where we create multiple provision identities, each implementing least privilege. Well, this is cool. Now we've implemented least privilege. By the way, too, we can implement algorithmic guardrails, right, that are deterministic when we pass data from one of those agents to another, but I'm trading one problem for another. I'm getting least privilege, but the problem that I'm getting in its place, unfortunately, is massive amounts of identity governance. And folks, this is yet another place that we have sucked as an industry. Identity governance is a hard problem. But if you had to pick the subset of identity governance problems that we suck the most at, it has to be non-human identities. And now instead of one non-human identity, as an actual case study here, right, for an agent that I helped build, ultimately we went to 18. Now I have 18 non-human identities. And I was born at night, it just wasn't last night, so I know that people are gonna reuse those identities. Never allow that to happen. They're going to look at that identity and they're going to say, that has all the right permissions that I need. I don't want to expand the identity governance problem by duplicating that identity. Cool, but what happens? 6 months from now, one of those applications using that identity is going to need a new permission. And it's going to get added, and now both applications have it. One of them is now over-provisioned, right? And this problem will explode, right? The only way that you can stop it is to never allow it to start. Right? Never allow it to start. By the way, I know I sound doom and gloom, but this is a spot where I want to say we are in an amazing position because nobody has agentic AI in prod right now. Okay, that's not quite true. Very, very few people have, or very, very few organizations have agentic AI in production right now. Practically everybody is evaluating it. Very few have it in production. As a real-world example, this Tuesday, during my lunch, I was on a round table with a bunch of credit union folks, credit union CISOs and CIOs, and they asked, 100 plus of them, in a poll, like you don't get 100% participation in answers, but they asked how many of you are experimenting with MCP, Model Context Protocol, and agents, and 78 people said yes. Nobody said no. Right? Maybe there were a couple of no's. Yeah, that's right. I think there were a couple of no's at the end. Initially, it was like, whoa, unanimous, right? Then they asked, how many of you have agents in production? And now we went from like this response rate of like 78 some odd, whatever, of the 100 and some odd people on there. We got 18 no's and 0 yeses, and it never went to yes. So this is a good cross-section. Again, this aligns well with what I'm seeing in my consulting base or my consulting client base. But ultimately, we're in a great position because this is such a nascent technology. We do not have to clean up the sins of the past. You can leave today, go back to your organizations, and help implement the governance programs to make sure this gets built correctly so that 5 years from now, you're not up on stage giving a talk about all the technical debt you uncovered, right? In these programs. Think about how often this happens. Seriously, I mean, in cybersecurity, we have some very nascent technology. The last one I can think of that would be this significant, where you can go build identity and governance and security governance programs from the ground up, has to be cloud, and that was almost 2 decades ago, right? I just don't have other examples. I mean, blockchain, if you want to talk about that abomination, but hey, let's not, right? And so let's talk about things that actually have use cases. And so anyway, looking forward here, insufficient logging, right? This is another huge issue. Side note, I know some of you have heard this story before, but I occasionally do some of that dirty influencer work. I hate that term, by the way. And I got approached by this influencer marketing company some years ago. It was 2018-ish. And they're like, hey, man, we've got a deal for you with steel chainsaws. And I'm like, steel chainsaws? I don't do anything with chainsaws, right? And they're like, you're one of the top people. You've been identified by our social media marketing platforms, one of the top influencers in log and log management, right? And I'm like, well, that is true, but we are talking about a different kind of logs, and so, wahaha, okay, this is when I knew Skynet was not coming to take my job. Right? By the way, seriously, right? I know there's a big delta between 2018 and 2022, 23, right? When the whole OpenAI, AI applications will, completely eliminate security jobs. But I'm going to tell you, that experience really helped me, right? To be like, I have nothing to worry about, right? Because I'd seen it in production where people these are actual folks who they are tasking to reach out to me and offer me a contract, right? Like, this is madness, right? You could have done like a 10-minute 5-minute LinkedIn search and been like, clearly not the guy, right? But over-reliance on AI systems for the win. Anyway, coming back to logs, right? The vast majority of LLM applications, actually, you know what? I don't like to speak in absolutes. I'm going to say every one I've looked at lacks some logging someplace. Most of them lack it, particularly in accounting for non-deterministic behavior. You cannot just log the inputs to the LLM. You have to log the outputs as well, because I can't recreate the output from the input. I just can't. Right? I can recreate a facsimile, but I can't recreate it. Some folks are using Azure Foundry or AWS Bedrock or Google Vertex or what have you, and they want to go log that at the LLM layer. Well, that's fantastic, great. That's better than nothing. By the way, that's what Langsmith is doing. It's logging at the large language model layer. But you're missing all of the application context. I have to step back and say, why did this interaction with the LLM occur? Why this input specifically? I don't have that, right? And so I need to actually build logging into the app. Now, Langsmith, again, isn't going to build logging into the app. It's going to give you exactly this, LLM-level logging, which, again, is better than nothing. It's phenomenally better than nothing. It's just not everything. We'll call it necessary but not sufficient. Then there's lack of attribution. OAuth and OIDC, these are the foundational authorization mechanisms for most agentic AI systems. And it, hands down, is not up to the task of being used for agentic AI, period. If you're working at all in agentic AI, and by the way, these slides have been shared with, hopefully they'll get shared out through Discord, whatever. You can go download a copy of them. I'll upload them to my GitHub here in the next 2 weeks. I'm giving this talk again somewhere else, so I can't upload them right now. But they are on the Discord for everybody that's here. Alas, this, really go read this blog post. This is just a tip of the iceberg blog post where Microsoft starts and says, look, we've identified a problem here, right? When I authorize a client, right, so an OAuth client, to go and access resources on my behalf, right? Sure, I've authorized the client, but how is the client actually going and connecting to those resources? Is it that it's connecting to those resources as a single task? Is it connecting to those as an autonomous agent or a fully digital employee, right? Which is another term that I abhor a little bit, but you get the idea here. And by the way, this is a non-exhaustive list of issues, right? The TLDR here is that we do not have in OAuth the foundation to get attribution for why a particular task was performed, let alone under what context it was performed. OAuth and OIDC have to change. Right? Now, we brought these in. The reason we're using these today is not because they're purpose-built for this. It's because they were already here. Somebody looked and said, this will solve the problem. Right? I would also love to tell you that I've never seen an agentic application take a bearer token, pass it to another server, and spoof the client ID as it contacts the resource server. Because this, my friends, would be a huge security violation and definitely not in keeping with the OAuth spec. I unfortunately, as I'm standing here today, can not only not tell you that I haven't seen that, I've seen it repeatedly, almost to the point that I'm trying to hunt down which developer has posted a blog about how to do this as a design pattern so that I can send a Terminator to murder them. Anyway, we've talked enough about problems. Let's talk about solutions. All right? So I hate to call these just potential controls, but that's exactly what they are. So first, before we get started, I want to ask, what do we even mean when we say control? Is it a technical control that prevents a particular action from occurring? A process control that prohibits a risky action from being taken? Technical controls that facilitate detection of an error condition, but we don't block it? What about process controls, logging controls, right? One of the things that I have to do when I'm working with organizations in fixing the outcomes of AI risk assessments ultimately is to redefine or at least expand the scope of what they consider to be a control. With most organizations and most CISOs, they kind of step back and like, are you blocking it? I'm like, no. They're like, well, then it's not a control. And I'm like, you're absolutely wrong about that. I don't deal with that as much in financial services because they have lots of process-based controls outside of cybersecurity, so they understand that a little bit better. But ultimately here, I want to get to a common understanding of what we even mean by that. So we get into logging, right? No incident responder ever, if you have incident responder friends, go ask them. They will confirm this for you. Has ever said, wow, what am I going to do with all these all these logs, yay. Log early, log often, right? That's the key here. And I have to step back first and enumerate investigative scenarios and say, are our logs sufficient to answer likely questions in these investigative use cases? The answer is usually no, right? One other big thing here, because we are logging typically prompts and responses, you have to, 100% have to, think about data locality laws as well as information disclosure through your logging. I want you to think about some of the stuff that you've put in the past in ChatGPT or Copilot. Actually, I'm in a room full of security professionals, so this probably isn't as good of an example as it usually is. But I kind of talk to folks about, like, think about whether or not you want a security operations center. When I go talk to a CEO, a stakeholder, what have you, I ask, do you want your SOC analyst, especially your offshored contract SOC analyst on a BYOD machine, probably still running Windows 7, do you want them reading your prompts and responses as you've interacted with Copilot? And the answer to that is universally no. Not no, but no. And so we really need to think about this because the just send it to the SIEM, like we do with all other logs, does not work here. Right? We have to be really, really careful about this. So I've already talked a bit about this. I'm not going to hammer it too much farther, but logging has to be implemented in the application, not at the LLM. If you only do it at the LLM level, you're absolutely losing application context. I know refactoring applications is costly. As I mentioned before, I'm doing development work. I'm doing development work specifically in AI. I hate refactoring. It costs money. It is a drop in the bucket. It is a rounding error compared to paying incident responders the inevitable fee to go through and try and deconstruct what they can from your insufficient logs. So, another fix that we can use is Llama Guard. Now, before we all hate on Zuckerberg, let's be fair, that's a fun thing to do. But before we all hate on Zuckerberg, let's talk quickly about the fact that Llama Guard is actually useful. Llama Guard is a content filter. It's an open source content filter that you can run yourself. Now, there is no free lunch here, right? Llama Guard, of course, because it uses an LLM as a backend, it is going to increase compute requirements because what you're doing is you're using an LLM to classify either the prompt or the response or both for various types of harmful content defined by you. They have a bunch of predefined ones, like they say bulimia or suicide or cooking meth, right? Building bioweapons. Those are all harmful, use cases, right? But again, beautiful that it doesn't require a commercial license. Again, downside, increases compute requirements, your API costs go up. a lot, right? And it adds latency to your application. Very critically too, from a user experience side, although I'm not a big UX guy, that's not what we're covering here, you can't stream if you're using Llama Guard. You can't stream a response because the LM first has to classify the response, right? So the whole response has to be done and sent to Llama Guard first before you can send the response to the user. So when folks come back to me and say, we want that nice streaming output because it's cool and that's what our users expect, I'm like, well, then we can't do this. Pick one, right? So then prompt firewalls, right? Prompt injection, as we talked about, can't be fully mitigated. There are some tools out here for this. Again, they all increase cost, they all increase latency, they all prevent streaming, right? But there's something at least, right? Prevent streaming depending on how they're used, right? Rebuff from Protect AI, this is now defunct as a service, but they still have the code available so you can deploy it yourself. There's commercial tools. Witness AI is my favorite by far. Akamai's AI Firewall is a close second. Look, from the prompt injection side, 6 to 1, half a dozen another. Witness AI has a bunch of other governance features that I like, right? So that's why I usually use them first. Azure Prompt Shield is a platform tool. It is phenomenally less, it's cheaper, way cheaper, like order of magnitude cheaper, but it's also way less reliable, right? So to the extent that any of these are good, Azure Prompt Shield is probably the worst. And then you can also use Llama Guard for prompt injection detection. I would recommend making a second call to Llama Guard, one for prompt injection, one for content safety. Again, increasing latency, cost, et cetera. I have found trying to combine the two of those together does not work well. You get a lot of really bad results in both sides of things. One of my biggest controls that I've thrown out is limiting the size of input prompts. I can't always do this for all use cases, but for a lot of use cases I can. For a lot of use cases, I'm able to go in and say, hey, I only expect a sentence, 2 sentences, right? 300 characters, whatever that is, from the user. If you've seen a bunch of these do anything now prompts, they are paragraphs of data, right? And so lots and lots of data there supplied to the LLM. Well, look, if my use case can constrain the input size, I can stop a lot of do anything now, which is a very specific form of prompt injection. I can stop it in its tracks. If you're going to limit input size, and I got to tell you, I died inside a little bit, right? Every time I have to remind folks or write in a report, hey, please don't only limit input size on the client side. Have we learned nothing over the last 25 years of web app pen testing? Please, if you're going to limit something on the client side, limit it on the server side too. By the way, I'm not saying don't also limit it on the client side, right? Defense in depth, that's fantastic. And honestly here, right, it's better because I'm never making the request to the server for most users, but any idiot with burp, right, can open that up and they've completely neutered our defenses. Let's not do that, right? So, I want to offer a couple of quick recommendations. Maybe these are hot takes, I don't know, something like that. First off, I want to determine whether my tests want to focus or need to focus on breadth or depth. Every organization that I work with has a fixed set of resources. When they come to me and say, hey, we're going to go assess this AI application, or we want you to assess this AI-enabled application, there's a fixed amount of money, right, that they are willing to devote to the project, and that constrains the test. And I have to focus either on breadth, running a huge number of use cases, or depth, running the same tests multiple times, because non-determinism, right? And so there's no universal for a best balance here. This is where, in my scoping, I am dedicating hours, right? So scoping of the original test before we get into the specifics of it. Once we've signed that statement of work, I've got time built in there for stakeholder education, right? To help them understand the nuance of this, how this is different from other application tests that they've undergone. You can't step back and be like, wow, these idiots, right? This is a nascent technology. It's a new technology, right? It requires a mindset shift. Somebody has to educate them. Let that be you. It's mutually beneficial, by the way, right? It actually increases the likelihoods that they think your outcomes are successful. Also, again, right? If you just go in YOLO and you're like, and pick one of these, I guarantee you it's the wrong one. I guarantee you the stakeholder would have gone the other way, especially with the benefit of hindsight bias. They will definitely tell you they'd have gone the other way. So educate them. Help them help you, right? But at the end, make them pick, right? Anywho, so my next piece of guidance here is learn to program or rent a programmer or something and create test harnesses. Once I get the LLM to generate an output, I do not want to rely on the LLM ever generating that output again. I'm going to create a test harness, a particular adversarial output. I'm going to create a test harness that just supplies that at the right spot in the application. This sounds suspiciously like it's undoable in black box testing, because it is. This is why you can't do black box testing reliably. I need to understand the data flow. I need to be actually hooked into the data flow so that I can create a test harness so that I get repeatable outcomes so that I can test further into the application flow, right? So if you're familiar with this or if you've done any work in traditional binary vulnerability discovery, there's a parallel here called SMTs. So if you're interested in that and you want to go Google that and read up on that, what have you, and they use something called taint tracing a lot, right? And so we're not taint tracing, we're just tainting at every step of the app, right? So, but alas, to do that, I need test harnesses. For autonomous systems, I'm going to enumerate failure modes. This is hard. This is just hard. I want to get engineers, though, preferably those not involved in the design of the application, because they have a hard time calling their baby ugly. They get offended when you call their baby ugly. Get engineers not involved in the design of the application to throw it at the wall and see what sticks. I want the worst case outcomes from the combination of tools and data available to the autonomous system. My biggest pro tip here is that you should never, ever take rescoping, and I should be honest here, descoping, decreasing the scope of the application. Never take that off the table, right? That's how we end up, honestly, after most AI risk assessments that I do, that's an outcome. We are rescoping the application because as designed, there are some things that we can't control and put inside the organization's risk appetite. Finally, I want to use algorithmic guardrails to restrict MCP tool use. MCP, Model Context Protocol, right? MCP clients can, in fact, limit which MCP servers and which tools from those servers are used for a specific operation. This requires step-specific code to be written for that specific step in the agentic workflow. Who thinks that happens very often? Me either, right? And so, but you can do this. Look, MCP is a dumpster fire. The S in MCP stands for security. I regularly tell people that MCP is a protocol built in 2024 with telnet-grade security. It's not that you can't use MCP, it's that it takes a lot of work to get it right. Okay, you're still not getting it right. There's still huge dangers with it. It's still a dumpster fire, right? But you can make it less of a dumpster fire, like a smoldering dumpster cookout, right? Instead of a raging flame. Anyway, long story short here, get with your developers, work with them to enable good outcomes. Finally, I want to wrap up with a couple of closing thoughts since we're right at time. Look, risk assessment of AI apps is hard. If you're using a traditional risk assessment or threat modeling framework like Stride, I promise you, you're failing. Like 100% promise you, you're failing. My final thing here is that I don't care how awesome you are at doing AI risk assessment. You could be the best in the world at it, right? Skills get the shells, reports pay the bills. If your reports do not communicate adequately to your stakeholders in a way that they can understand, why did you do the test in the first place? You're not increasing security. We've already talked a little bit here, about the non-determinism, the requirements to agree on reporting outcomes, what have you. Again, I want to close with that because as unsexy as reporting usually is, right, it is probably the most important thing that we do in any given assessment, and doubly so here because we're reporting on something that we understand well, but our stakeholders really do not. And the development teams that are going to fix it, doubly so. Folks, thanks so much for your time. Have a great WWHF Hackin Fest. Thanks to Anti-Siphon and WWHF Hackin Fest for having me out again.